Hello everyone, and welcome to a new session on generation of wind load in STAAD.Pro Connect Edition. I am Surajit Ghosh, and today I'll cover how we can easily generate wind load on different types of structure, including industrial building, following the guidelines of IS875 Part 3, 2015. First, I'll cover some basics of wind load application, how wind load acts on different surface of any structure, whether it's a cladded building or an open structure like a railway platform. Then I'll cover different methods of wind load generation in STAAD, both manually and using the newly implemented auto generation feature. Also, I will discuss about few automation techniques using which we can generate complete wind load specification for any type of structure. There are few limitations of wind load generator. How we can overcome those using a custom macro, that I will cover in detail. It is divided in 3 parts. In the first part, I will cover the basics of wind load application and discuss about wind load generator. Let's start with some basic. When wind load is applied on any face of a structure, how it is distributed to different parts, that depends on several factors including the structure geometry, opening, any obstruction. Based on this condition, we need to apply wind load properly on different structural element. For example, if we consider a cladded building like a residential building with external brick wall or commercial building with glass cladding, wind acts directly on the external surface as a pressure load. This load is transferred to the supporting frame member as nodal load or UDL. Other part of the structure like back or side walls are also subjected to wind load due to wind flow. But if we consider any open frame structure or tower, there is no external covering. Hence, wind acts directly on the member of that face as member load and all subsequent frame if there is no obstruction. So, the nature and application of wind load might be different for different type of structure. We can categorize it as cladded structure like any residential building or warehouse which is completely or partially covered at the outer surface with brick wall or panel. We can further categorize this as flat roofed structure with concrete deck like any multi-story residential building, and sloped roof structure like pitched roof factory set or monoslope roof. For unclad structure, there is no external panel. Any open frame structure like a plant unit with exposed frame or pipe rack structure comes under this category. Also, there are few other types of isolated open structure like a transmission tower or freestanding hoarding and wall. These are few common structure. There are several other like circular tank or building with canopy or dome type of roof. Those will not be covered in this discussion. For each of these structure, application of wind load is different. If we look at IS875, we can notice that code suggests different guideline and clause for each category, which we need to follow during load application. How we can achieve that using wind load generator in STAAD, that I will discuss today. Wind load generation for cladded building structure will be covered later in detail. Wind intensity increase with height, and for wind analysis, first we need to compute this height versus intensity data. For any structure located within India, we need to calculate the wind pressure as per IS875 Part 3 using the empirical equation mentioned under clause 6.3, which calculates the design wind speed based on the basic wind speed at that location and few factors which depends on the topography, terrain condition, presence of other obstacle. Then this designed wind speed is used to calculate the designed wind pressure following clause 7.2 with proper direction, area average and combination factor. Finally, clause 7.3.1 or clause 7.4 is used to calculate the wind load on individual element like wall, roof or member. A is the surface area of cladding unit for cladded structure and exposed member area for open structure. In this equation, there is an additional factor which either increase the overall load or decrease it. This factor depends on the wind direction, structural dimension, opening, and it is very important for proper wind analysis. In this equation, we are considering the net pressure which is acting on the panel. CPE is the external pressure coefficient which considers the wind effect from the external side. CPI is the internal pressure coefficient which considers the effect of wind inside the structure. How these pressure coefficients are calculated and used for analysis, that is a large topic, and I am not going to cover this today. Rather, I will only discuss how we can find the correct value from relevant table. CPE for wall of rectangular clad building is available in table 5. For any structure with sloped roof, we need to use table 6 for pitched roof and table 7 or 8 for monosloped roof like a bus set or railway platform set. There are other tables as well, from 9 to 24 for different shape of roof. Internal pressure coefficient depends on the opening size, and based on clause 7.3.2, we can determine the coefficient for different opening size. If there is any opening in the external wall, wind enters the building, then tries to escape from other opening. Hence, there is a distribution of pressure which is applied on different surface of the building, and it depends on the opening size and direction of wind load. If the opening increase, more wind enters the structure, which eventually increase the internal pressure. For example, consider figure 2, which indicates the possible direction of internal load based on the wind direction. If wind acts from positive x direction, it enters the structure through opening and all walls are subjected to outward pressure, whereas for z direction wind, there is no opening, wind can't enter inside directly, but there will be loss of internal pressure due to opening. Hence, wind load due to internal pressure is changed to suction. Depending on the nature of opening and other factor, internal pressure can oppose the external load or increase it. That's why court suggests to consider both this condition during analysis and use the results which produce Oorst effect. By the way, for each wind direction, we need to combine all load components applied on side walls and on the roof. For any multi-story cladded building like a residential or commercial building, it is relatively easy to apply wind load as we only need to consider pressure on the walls. Wind load on the roof is not that relevant as the deformation of rigid concrete deck due to wind activity is nominal. We can easily apply wind load on any such structure using the wind load generator available in STAAD. Since STAAD.Pro Connected Edition v22 Update 8, a new feature has been implemented using which we can generate wind load on any cladded building structure following IS875 Part 3. For this building, we can use the wind load generator to add wind definition, wind load case, and combination of loads from different direction in a single click. Only we need to provide some inputs required for wind pressure and coefficient calculation, like where the structure is located, topography, terrain, and other factors, based on which height versus wind intensity data is generated. Basically, this creates several wind definition based on the input. Then we can provide the external pressure coefficient value at different face of the structure. For this, we need to consult table 5 of IS875 and find the value based on the structure dimension. We can also consider the internal pressure coefficient by providing proper opening size. That's all. Based on this, wind loads are automatically added to the model. This generator can identify the members in each face of the structure. Also, we can use custom group or member list for the generation of wind load. As you can notice, several wind load cases are added to the model. Under each load case, wind from a specific external direction is considered, and all possible internal pressure on the walls from different directions are combined, considering both positive internal pressure and negative internal pressure. Easy, right? Using this wizard, we can generate all relevant wind load case in a single click with minimal user input. Though for any high-rise structure, only these wind loads are not sufficient. There are several other criteria which is required to compute the applied wind intensity value, like the drag and vortex shedding effects. Another important factor is the interference. In IS875 Part 3, it is clarified under clause 8.3. For any tall structure, we need to find out the interference of wind due to presence of other building structure located in the catchment area. Depending on the dimension of the building, the area is determined. Then, depending on the height of other building, the interference factor is computed, which determines the final wind intensity on the tall structure. That's all for today. In the next part, I'll cover how to generate wind load on wall and roof for an industrial warehouse structure. Keep watching.